Did you look over the first one? Any questions? I do want to see the steps as you go. Even if you just have a pencil, just keep drawing the steps, because when you have to get to the domain, I didn't ask you for it on the sheet, but watch, we're going to do the domain and the range on these guys. So you're going to need to go step by step.
On the test, would you want us to also draw the different...
Yep, I'm going to want that. Exactly. So you're going to start out order of operations. Start with the x, parentheses first. So here's your 5. This is a horizontal shift left 5. God bless you. Make sure you're using the right words. Then we have a reflection out here. That's like a -1 out here. We have a reflection in your x-axis. If you feel more comfortable, you can take this 2 and put it over here. If that makes it look better, makes it make more sense, that's absolutely fine. There's your vertical shift up 2 units. So, was there any change in the domain? What is the domain of the squaring function? Good. So does my domain change with any of these transformations? Well, it would, because I did shift it, but because I'm all real numbers, does this particular one have any effect on it? I'm still going to be all real numbers, right? And it does, I did a horizontal shift, so it does affect domain, but in this case, I'm all real numbers. Is there anything here that affected your range? What would you see, Connor, that affected your range? The reflection. So the first thing you had was a reflection. Your range started out as 0 to infinity. So your reflection in the x-axis made your range become what? -infinity to 0. And then what else affected your range? The shift up 2. So you were just ahead of me one sec. So the shift up 2, we just add 2. So I'm just going from -infinity to 2. So you're going to have to go step by step to get those parts there. Okay? Mark, do you have the, I collected this, and then I checked off the homework. You don't have the homework? Okay. Questions at all? Stop me if you have any questions. Can you see it okay?
Yes.
I see Teresa went a little, and she's right in front. So can you see this all right? Or I can make it bigger. It's the light. It's a glare. Better? Yeah. I could even shut this door, because this door gives me glare. All right, so again, you're going to start in here. It's a squaring function. So our parent graph is a squaring function. We're going to start right in here. So we have a horizontal shift right 4. So let's walk step by step. Normally my domain has an effect on a horizontal shift, but my domain is all real numbers, so I don't have a problem with my domain. I come out here and I multiply it by 2. I multiply it by 2. What does that 2 do? Vertical, good. A vertical stretch, and I want to see it. Vertical stretch by a factor of 2. I want to see you write that. Okay? It's a dilation factor. We work these things, we call them factors. Everything has to have a factor of something. Even a shrink has a factor of 1/2. Don't say divided in 2, say factor of 1/2. It's a vertical stretch. So does that affect my domain or my range? No. I'm just making this a little bit narrower as I pull it up. I shifted it and then I pulled it up. Now I come out here, and if it's better for you, you can put it over here. There's my vertical shift up 3 units. Does that have any effect on my domain? My range?
Yes.
So I'm just going to take my range, I'm going to move it up 3 units. So here's my new range. Okay. I didn't ask you to do the domain and range, but I wanted to do that part with you guys. All right. Okay, a cubing function. These are hard to draw and to see where these are going because they're just a squiggle line. So you're going to start again inside the parentheses, order of operations, and your parent function is your cube, so that's fine with the cube out there. That cube doesn't affect your order of operations here. This -2 says move me horizontally 2 to the right. So I just start and I move it 2 to the right. None of these will change your domains and your range. How come?
Because it's all real numbers for both.
Good. All real numbers for both. So my domain and my range are not going to have any effect. I come out here, and it's multiplied by 3. So if I multiply something by 3, do I increase it or decrease it? Increase it. So is it a stretch when it's an increase or a shrink when it's an increase? A stretch. Makes sense, right? If I decrease, I get a shrink. So I stretch this thing vertically by a factor of 3. And sometimes it's hard to see where to write this, but what you can do is this. If my new one is here, my stretch, if this is my other one, my stretch should be from here, it's inside because, like, just picture this one here. Say this was like a 1, 1. If you're going to go 1, 3, it's going to move it inside. A shrink is going to move it halfway there, outside. So just like pick one point just to see if you are inside or outside of it. You see what I'm saying? Your cube is 1, 1. So just pick this 1, 1 point and then multiply this guy by 3. So now your point's going to be 1, 3. So that's going to, instead of 1, 1, I'm going to be 1, 3 up here. So it's going to move it inside. Okay? And again, no effect on your domain or your range. Stop me if you have any questions. Inside the parentheses, I have a horizontal shift. Does this affect my domain or my range again? Nope, I'm all real numbers. And then I have a vertical shift up 2. Guys, when you come in late, you got to sign the late book. Okay, good. All right. This one has a little busy stuff going on. Inside the absolute value first, order of operations. I horizontally shift right 1. Then I come out. You can just sign that late book. Okay, so I come out of here. I don't change my domain because my domain happens to be all real numbers, just like the squaring function. I come out of here, and then what do I hit? I come out of the absolute value, Matthew. What do I hit?
What?
Mike, what do I hit? Now, I'd pay attention if I were you guys. So next week, guys, seriously, I want you boys spread around here. You're kind of like dormant back there. You need to get involved in this. I come out of the absolute value. Eric, what do I hit? When I come out of the absolute value, what's my next step? What am I going to do?
You do the vertical stretch.
Vertical stretch. What do I do with this negative? Do I vertical stretch it by a -2?
No.
No. Good. I only vertical stretch it by, I can't stretch anything by a negative number. If I'm moving its distance, it has to be a positive direction. So I stretch this by a factor of 2. The negative is a reflection. Yes.
I thought it was 1 step.
No, well, no, you could write this as 2 steps. I have a vertical stretch and a negative reflection.
Yeah, I mean,
You
they
could-
could go both ways.
You could write this 2 steps, 1 step, but you still have to list them both. Like you could put this as 3, this as 4, which I normally do, but I just figured put it in here. As long as you write them 2 different things, you can't write them -2.
Yeah, I know that.
Yeah.
It's in this one thing.
Yeah, you can call this anything you want, but make sure you just list these 2 different ways. If you want to include this as in this part I'm doing this, that's fine. I write them all different ways so that if anybody writes it that way, you can see it's absolutely fine. Usually, like, my stuff has a lot more work in it, just because I'll catch everybody's stuff that they do. Makes a little bit more sense. So this guy's going to give you a negative out here. This is your reflection in your x-axis. What changes as a result of that reflection? Domain or range? Range. So what does my range become as a result of this?
Flips the y becomes the
My range? My range becomes negative infinity to 0, right? It flipped over the x-axis. It reflected over the x-axis. Go left. Now I'm going to vertically shift up 4. So what is my new range? Negative infinity to 4. Oh, I'm going down. Sorry, going down 4. Sorry. Down 4. We're going down 4. So negative infinity to negative 4. One step at a time on the domains and ranges. It's nice when they have no change, but sometimes there's a lot going on. This one had a lot too. Start inside your radical. Inside your radical, horizontal shift, left, 3. Okay? My radical is like one little arm. My radical has a lot going on. It has a domain from 0 to infinity. It has a range from 0 to infinity. Okay, so I shift left 3 units. What does this affect right here? The domain. So what does my domain become now?
3.
I'm moving left. Negative 3 to infinity. Keep track of what's changing. Then I take a vertical shrink out here. Why? Why is this a shrink? Because it's 1/2. If I cut something in half, don't I shrink it down? If you have 4 things and you shrink it down to 2 things, right? You're shrinking down.
I've never makes it wider.
It makes it wider because you're changing the distance to 0. So when you change the distance to 0, you actually make it wider. Okay? So we make a little wider. And then we're going to make a reflection in the x-axis. So this reflection, what does that change? The domain or the range? The range. So what is the range now? To 0. I just reflected it right over the x-axis. And then the last thing I'm doing is what? Vertical shift down 1 unit. What does that change? The domain or the range? Range. So what is my new range? Okay, so here's my range. Here's my domain. One step at a time. It looks weird because on a radical one, you're kind of starting smack in the middle of the graph, it looks like. But that's what happens because it's only a little arm here. Questions at all? Yes. Oh, reflection, no. Just tell me what caused that reflection with that negative sign. That negative sign caused the reflection. Yeah.
If we just go back to
Mm-hmm.
so you said if we just write reflection, that'd be okay.
No, I want reflection in the x-axis.
Oh, yeah, I mean, it's over there.
Yeah. You have to tell me which one. You don't have to give me the rules. I write them. I write them down there. But I always add a lot more on mine, probably. Different kids see different things. So if you're more like that, you like to see the rule and the thing, I write them down. I don't expect as much work as I just try to put what I think kids would look at. And I try to do them a few different ways so it kind of catches everybody. Differential learning. Okay? Okay. So today we're hitting the last topic of this. It's not a hard topic. But the only thing that is my mistake, I put it on a slant to say great. Thank you. Okay, why don't I just make this an independent study? Why don't you guys do this on your own then? I don't need to keep standing here saying stop talking. But what?
have the calculator now.
No, I have to get them from Mr. Chambers. Hopefully I will have them by Monday. I'll just ask him for a whole bunch. Okay, we're doing, and you looked at these last year, and we do this mostly on a graph. In Algebra 2, we do this. We take functions, and we just add them together. We subtract them, we multiply them, we divide them. Very basic. The only thing we have to worry about is the domain. And which one of those operations would affect my domain? Sum? Product? Quotient?
I think close.
Not product. Quotient. Why quotient?
Because it can't be 0.
Because a fraction can't be 0 in the denominator. So the fraction is the only thing that's going to give us trouble. We're going to find the original domain, and then we're going to worry about what's going to happen to the fraction. Okay. So the first one, we have no domain restrictions. We have a line, we have a parabola. No domain restrictions, right? Okay, so when we add these together, we do just that. We take function f, and we add it to function g. Okay, and we simplify, collect your like terms. So I have an x squared, I have a 2x and a 2x, and a 1 and a negative 1 will cancel out. So there's my sum of these guys. Now, and your compositions that you used to do, your composition functions, remember you needed f of g, and you put one equation into the other? So sometimes you substituted in a number into both of them, and then you did it, and sometimes you just found the rule, and you did the final rule, right? So now, when I need to find the sum, when x is 2, I just substitute it into this equation. I don't have to substitute it into this one, and then add them together. So we'll do it just so that you see it. So when I substitute it in here, this gives me 4 plus 8. This gives me 12. If I put a 2 in here, this gives me 4 plus 1, 5. 4 plus 4, 8 minus 1, 7. If I add the 5 and 7, I get 12. It's kind of like function notation. If I gave you this, and I said add this to these guys, or if I did this, I remember doing it with the 3, like the composition one. You would do this, and then plug it in here. Then remember finding the equation, and then just plugging 3 into your final equation. Sound familiar at all? Okay. So you can do it like, it's kind of like the composition thing going on here. But we're just going to say add, subtract, multiply, divide. The one that gives us trouble is the division one. So we're going to take a look at these guys first. And we're going to say, are there any domain restrictions with radicals?
Yes.
Yes. A radical, under a radical can't be negative. So it can be 0 because there's no fraction. So we're going to say x is greater than 0, greater than or equal to. Okay. So my first one, not a problem. I can throw that on my number line. My second one is a quadratic. So the rule with the quadratic inequality says, set this equal to 0, find the factors, plus or minus 2, put these on your number line. Let's put the minus 2 and the positive 2 here. Which way does my parabola open?
Upside down.
Upside down, good, because of the negative. So I want where it's positive, I want right in here. Now, here's my other problem. I've got another one here that says x is greater than or equal to 0. So on mine, I also have to say this. So what's my domain? 0. If I use 0 to infinity, can I put a 3? So 0 to where? 0 to 2. Those are the only numbers I can use that will satisfy both of these. See it? This was a quadratic inequality. So I've got to have some kind of interval of numbers that I can use. So I lay that out on my number line, and then I say, oh yes, that one can use greater than or equal to 0. If I put a negative 2 in here, will that work? So there's no way I can ever add them together that way. So now, my next step is this. I divide these. I take my function f, and I divide it by my function g. Okay? You don't have to, that's a minus sign. You don't have to rationalize denominators in precalc. So we can leave it like that. There's no way to reduce that. There's no way to take that x out of there. This on the bottom is an x plus 2, x minus 2, so that's not a perfect square. You can't take the square root of 4, the square root of x squared. But what's going to change? What's going to change here? The domain. How come? Now you can't be 0. Good. So what's my new domain going to say?
1 to 2. Soft bracket 0 to 2.
Can I use a 0 here? Can I plug a 0 in here?
No.
0 would give me 4. Square root of 4 would give me 2. So I can use a 0. Can I use a 2?
Oh.
I can use a 1. Can I use a 2? This goes back to this guy right here. All that's going to change is this thing right here. It now cannot equal 0. Just like Mitch and Anthony said. So now all that changes is this. Soft bracket. So with the division, put an asterisk here, a big one. With the division, your domain will change. This causes your domain to change. This is the troublesome part we have. Yes, we got.
Wait, why is there soft bracket on 2?
Because now, this piece up here, down here, this piece up here, said I could use plus or minus 2 from there, right? But when I put it in a denominator, I cannot let this equal 0. So the 2 and the negative 2 will make me equal to 0. The negative 2 we did away with because of the other one having to be greater than 0. Does it make sense? Domains play a big role here. Yes?
This is like kind of all topic, but how much percent is testing for this your final grade again?
See me at the end of the period. So, any questions with this? Okay, so now, we're going to continue this and we're going to put this in here. We're going to do g divided by f. G says 4 minus x squared. F says, now, how does, my domain over here was 0 to 2 when we started, right? Now what change will I have here?
0 is soft bracket.
Can't be equal to 0, so 0 gets my soft bracket. How about 2? Hard bracket. I can still use 2. I can get a 0 in my numerator. I'm okay with that. So, overall, when we move this into a denominator, we've got to look at this again.
Why don't you do the negative 2?
Because what happened here was this guy says I need to use from 0 to infinity. So if I used a negative 2 in here, would that work? So I can't use this piece right here. Remember, I have to use where they overlap.
Oh, yeah.
So where they overlap is just this place right here. I can only use where they overlap. So this makes sense, right? All right. Again, evaluating your domain. Let's walk through one more of these. got to take a look at my domain. I need my domain to include both of these things because these are where my compositions come from. When I need to use both of those functions, I need my domain to encompass both of those. Does this domain have any restriction? X squared minus 9?
No.
No. It's a parabola. I'm cool. This guy, under a radical. Greater than or equal to 0. So I can't use from -3 here to +3. Am I opening up or down? Down. I've got a negative. So I'm down here. So the only things I can use is here. I can't use here or here. So my domain says -3 to +3. Now, do you guys remember how to do this? Plugging one into the other? Okay. So we're going to start at the G, and we're going to put it into F. I like to go like this. I put my G first. I put my F. I take this whole thing, and I substitute it into X. If it said F of G of 3, wouldn't I be putting a 3 in there? So if it says F of G of X, it means I need that whole function in there. I need to put this whole thing into this X. So I'm going to do squared. So the square root cancels out. I get 9 minus x squared minus 9. I simplify it. So what am I left with? Negative x squared. So this guy is equal to negative x squared. Is that going to change my domain at all? Did I add any more restrictions? No. Sometimes you might get a 1 over x. So if you add another restriction, you're going to have to worry about the 0 part or something. But this guy leaves me no other restrictions, so I'm good for that. Now remember, f of g and g of x are different. Brian?
Wouldn't the negative 9 go inside? Inside the...
No, because this is my function for this. I'm only replacing this x with whatever was in g. So put parentheses just around the x, slide it in. That's my square root of 9 minus x squared. When I square it, it pops out, and I have my minus 9 left over. I have to bring it down.
And what if the negative 9 was a negative 9?
Then I would have to substitute it into that x. If it was this, then I would have to substitute it into both of these. Yeah, but right now that's kind of like tailing, like it kind of tails behind. So I just add it behind there, and then I can do that. That's a good question, though, because that 9 kind of gets confusing because we have a 9 in the other one as well. Okay. So I think you guys should probably be good with this. Okay. Can you come up with, last thing, I want to do an f of g or a g of f or a of h of something and come up with this as my final answer. Can you give me 2 equations that, this is an h, so probably like g of h of x. Can you give me 2 sets of equations that will come up with that as a final answer? I want you to think backwards.
Well, the first one would be equals
So which one, g of x or h of x?
h of x would be x minus 2 squared, and then the second one would be 1 over x.
Okay, so let's see if this works. So we're going to take his h of x, you got to think backwards, and we're going to put it into this x squared. Do we get this? Yep. There's more than one way to do this. There's more than one way. So that works nicely. So I just want you to think those parts backwards. It's a good thinking thing. All right, so you're going to do that worksheet for homework.
All of it?
Yep. Oh, I'm sorry, we have one more to look at. Just let me show you this last one, because this is also on the homework. One more to look at. This, you guys shouldn't be bad with, because this is a lot of algebra 2. So I want to add the value of my function. The value of my function is my x or my y. Your y. So I'm going to take the value of f and add the value of g when x is 0. So on my graph, I go to the 0. What's the value of my f function at 0? 2. Just find your y value. 2. What's the value of your g function?
-1.
-1. Just add them together. So let's try it at 1. At 1, what's the value of my f function?
3.
What's the value of my g function?
0.
See it? Works nice on the graph. At 2, what's the value of my f function?
1.
Is it 1? Okay, 1. And what's the value of my g function?
5.
Okay, 0.5, so 1.5. Everybody see what we're doing? Comfortable with it? The value of your function is your y value. So at the x, locate its y. It's the same thing if I looked at the table. But I don't have a table, I have a graph. So you're going to see that on your homework as well. And if you have to subtract them, you subtract. Find your pieces. If it says subtract, I just come in here and say subtract. If it says multiply, I just come in here and say multiply. If it says divide, I go there and say divide. Okay? So homework, do this one. They're not bad. It's not a lot. Yeah.